on sale?
Everything's on sale.
Everything's on sale?
Yeah.
Where?
Steam.
City
City Center.
City Centre.
The clothes, shoes, and food, everything on sale.
Yeah, I went shopping last weekend in Northern Ireland.
Yeah, I know. You told me before.
Yeah, got good sales. Okay, the last homework. Let's see, where? Oh, Hareen! I don't think I'll give you a practice physics test in class, unless you really want it. But I think it might be better if I just continue practicing exam questions.
The new one or the last?
Oh no, today we'll continue with the last one. But first I'm going to do the homework. With the homework?
Yes.
Well, we'll do it now. So the lowest energy an electron can have when orbiting a proton is minus 13.6 electron volts. This is E1. The second energy is minus 3.4. Okay, so let me just draw that first. So here's your proton, here's E1, and then here's E2. E1 is minus, what did I say? 13.6. And E2?
Minus 3.4.
3.4.
Yeah.
Okay, so the question is, how much energy is lost if an electron falls from 2 to 1? Okay, so that's it. First one, I hope, is easy for you.
Why is the energy negative?
Oh no, please, I'm so sick, Hareen. I'm so sick. You know the answer to that. Can someone please tell him?
Because it's an electron.
No! Somebody please tell Hareen why.
It's trapped.
Please.
What?
Hareen, I'm so sick. Don't do this to me, please.
What?
He wants to know why it's negative energy. I know. No coffee today. Tea.
Why? Okay.
Tea and sugar will help.
Tea and sugar.
Yeah.
Okay.
It's going off and need energy.
Yeah, so when it goes down, it
Decrease.
loses energy. Oh, it's a 10.2, isn't it? Is that right?
Yeah, I guess.
So it's a lost 10.2 EV. That's oh sorry, I can't quite see. That's okay, isn't it? Yeah. So next, as it falls, the lost energy is changed into a photon. What's the frequency? So we can use E equals HF, F equals E over H, F equals 10.2 E over H. So now I take out my calculator. And H is number 6. So here we get 2.47 times 10 to the 15 hertz. Did you get that, Grace?
No.
Amanda? Did you try these?
No.
Oh, Amanda. Andy, did you try these? No. Irene? Guys, why? You didn't have your physics lab to do.
We got chemistry exam.
What about your physics exam?
We kind of exciting.
You see, the students do better in chemistry than physics.
Because sorry, it's scary.
Yeah. I don't want to be scary.
You don't want you to be scary as well.
But maybe I need to be.
No.
I try to be nice to me.
I'll be nice to you, not to Hareen. Okay. While in energy state 2, a photon is fired at the electron, and the electron just about reaches energy state 3. What is the frequency? Okay, so this one is also pretty easy. In this one, I want the photon to go from 2 to 3. What's the energy for 3? Minus
1.51.
Okay.
Oh, this is a big question.
Is it a big question?
Oh.
Is it?
I think it's a new one. I said, what? Why go straight to E3?
No, it goes to E3 from E2.
Yeah, because I thought B1 is a new question.
Well, it is. It can be. It doesn't matter. So to go from E2 to E3, you need 1.99 electron volts. Whoa. So here for B, you have 1.99 E equals HF. So F equals 4.81 times 10 to the 14 hertz. Yes? And then the next part, while in state 3 a photon is fired at the electron is freed. How much energy is required to free the electron? So when the electron is here, there was a photon fired here, and now there's another photon fired here, but now the electron is free. How much energy do you need to free it?
1.51.
Correct. 1.51 electron volts.
Oh, yes.
Is that okay? What are you doing in chemistry now?
We are still doing the
Calculate
Have you done this with Lorraine yet? Because you have done it already.
Yeah, the SP1, SP2.
Yeah. No, but that's
No, but I mean this thing with the different energies at the different levels. And Lorraine...
I think...
we just know the theory, we haven't done like...
Okay, because Lorraine also does this formula with you.
No.
No, okay.
Because no calculation in that part.
Okay, I think Lorraine will do this with you. But just remember that she uses this letter for frequency. Okay?
No idea.
Huh?
No idea.
I think you will do it with her. An electron accelerated through a potential difference of 10 kilovolts. It strikes tungsten with a work function of 7.2 times 10 to the minus 19 joules. What is the wavelength of the photon emitted from the tungsten? Okay, so what you have here is an electron, and here is 10, what did they say, kilovolts. So when the electron enters the field, it's accelerated. And then it hits some tungsten, a metal, and when it hits the metal, it releases a photon. So, my point is, it works backwards as well. So, just listen very carefully to this sentence. Okay, when a photon hits a metal, it releases an electron. You know this. But you can do it backwards. When an electron hits a metal, it can release a photon. So it can go both ways. A photon can free an electron, and an electron can make a photon. It's nice because it can go backwards. So in this example here, the electron hits the metal and releases a photon. So you're looking at this backwards. The electron has kinetic energy. There's a work function here, and then the light is released. But you still have the same formula. Ke equals minus work function plus, sorry, I don't want to get confused. Yeah, which way do we write in the book? HF plus work function equals Ke? No. HF plus Ke equals work function. Wasn't that it? No. I'm so tired and sick.
HF minus work function
equals Ke. Do we know the kinetic energy of the electron? Do we know how fast it's going? No, but the kinetic energy here of the electron is same as the potential energy here. Do you remember the formula for potential energy in a field? What is it? What is it? Q E D. Yeah. Now, do we know the Q? Yeah, it's one electron. Do we know the E? No. Do we know the D? No, we don't know the D and we don't know the E. Yeah, but we know we have a formula for E. Remember, it's V over D. And the D's cancel, so it's just QV. And we know that, look, come on. We have the V and we have the Q. So this will be E times 10 times 1,000. So we can put that in here for Ke. Hareen, in the question, what did I say the work function was? Or do I need to go back?
7.2.
Oh, you have it, Grace, thanks. What is it? 7.2?
10 to the power minus 90.
Like this? Okay, so if we put those numbers in, we can get HF equals I get this. Just note that I took this over to the right. So I have HF equals this. And we know both of these. So I can get this. What do I do to finish? Divide by H. So I get frequency equals 2.42 times 10 to the 18. Or if you want as a wavelength, let me put it as nano, or yeah, nano. Nano is 9.
Yeah.
Oh. Yes. No, I'll just leave it like that. Okay. The last part is what part of the EM spectrum is this photon in? So the frequency,
You have to look at this side.
yeah, the frequency, the wavelength is 0.12 nanometers. Now if you remember something like red light, what was red light? It's about, around about 550 nanometers. So what do you think this could be with such a small wavelength?
Microwave. Ultraviolet, right?
No, even smaller than that. This, in fact, is an X-ray.
How do you get the wavelength from the frequency?
Oh, please. C equals lambda F.
Yeah, that's all right.
Hmm. You worry me. Okay. Is this one okay? Yeah, can I close it? I can close it?